Today we're going to be talking about acids and bases, and this is going to lead into our next rubric, our next part of the chemical reactions rubric, which is the baking soda vinegar lab. So the first thing that we're going to talk about is acids and bases. So what are some characteristics of acids? Acids taste sour, they react with metals and carbonates, and they produce carbon dioxide, or CO2. They're corrosive. So acids, when combined with other substances, will eat away at those other substances. So like battery acid, if it gets in the engine of the car, it'll start to eat away at it. They react with bases. And some examples of acids are hydrochloric acid, nitric acid, acetic acid, citric acid, and ascorbic acid, which is vitamin C. Citric acid is, if you've seen commercials where they're talking for a lot of toothpaste, and they talk about the enamel being worn away from different substances, it's because of citric acid is what eats away at the enamel on, like, teeth. Some characteristics of bases are they have a soapy feel, they taste bitter, they do not react with carbonates, and they do react with acids. Some examples of bases are sodium hydroxide, which is also called lye. It's a very strong soap. They used to use it more commonly a long time ago. Ammonia, which is like a very harsh cleaner, like if you needed to do a deep cleaning like in your bathroom, you would a lot of times use ammonia. Soap, shampoo, quinine, which is toxic water, or tonic water, excuse me. So what's the difference between acids and bases? When dissolved in water, acids give off a positive hydrogen ion. So we know that that's a cation, and we know that that means that it's a hydrogen atom that has lost an electron. Okay, and remember that hydrogen only has one electron to begin with. And bases, when dissolved in water, give off an OH negative ion. So they give off a molecule that has oxygen and a hydrogen with a negative charge. So it's a hydrogen that's gained an electron. So that's an anion, and it has a negative charge. So what happens when we mix an acid and a base? We have a positive hydrogen ion and a negative oxygen ion, OH atom. Molecule, excuse me. When we combine them, they have a chemical reaction. Okay? They yield water and salt. Some type of salt. Not necessarily table salt, but it could be table salt. And the reaction type is it's a neutralization. So they neutralize each other. In many cases, but not always, this is what happens. So in the neutralization, we have an acid plus a base yields salt plus water. So an example is we have hydrochloric acid plus sodium hydroxide yields sodium chloride plus water. When we're measuring the concentration of acids and bases, we use what we call the pH scale. And a pH is a measure of the amount of hydrogen, of those positive hydrogen ions. So the pH scale is based around distilled water that has none of those positive hydrogen ions. And so that has a pH rating of 7 on the pH scale. So the more hydrogen ions you have, the more acidic something is, and that has a pH of less than 7. When you have less hydrogen, those positive hydrogen ions, something is considered basic, and that has a pH of greater than 7. So you may have seen people who have swimming pools. They put a little thing in and they look at it and they kind of shake it. And what they're doing is they're measuring the pH or the level of acidity of the water in the pool, and then or the level of or it could be too basic. And then what they do is they put in chemicals to neutralize it and get it back to where it should be so that it's safe to swim in. So something with a low pH has a lot of those positive hydrogen ions, and that's an acid. Something with a lot of OH negative molecules and not a lot of the positive hydrogen ions has a high pH, and that's a base. And then, so when we're measuring the concentration of acids and bases, these are some important things for you to know. The pH scale is not linear. So going from a 6 to a 7 to a 6 is not the same as changing from a 6 to a 5. It's a logarithmic scale. So, for example, each change in pH is a factor of 10. So going from a 7 to a 6 is, let's say it's 9. Going from a 6 to a 5 is 90. So each time you decrease, it's 10 times greater, the concentration. Going from a 5 to 4 is 900 times greater. But remember, each one is only a change of 1 in the pH. So if we look at this pH scale, what I want you to notice is that the acids are on top. So so right here, pH of 7. This is our neutral. This is pure water. It has a pH of 0. So saliva and urine have a pH of 6. So they're 10 times more acidic than pure water. Soft drinks, coffee, just plain black coffee, has a pH of 5. So these are 10 times greater than, 10 times more acidic than urine or saliva, and they're 100 times more acidic than pure water. So this is a 4. Tomato juice is 1,000 times more acidic than pure water, acid rain. And so each one, so grapefruit, orange juice, soda is a pH of 3. Lemon juice, gastric acid. Vinegar, pH of 2. Hydrochloric acid, that's secreted by your stomach lining. So if you remember when we talked about the digestive system, the acid that's inside your stomach is 1,000,000 times greater than the level of acidity in pure water. And yet it's inside our stomach, and typically it doesn't hurt our stomachs. It doesn't eat away at our stomach lining, which is pretty amazing if you think about it. Now, if your body produces too much, it can start to eat away, and that's what's called an ulcer. Or it can get into your esophagus, which is called acid reflux, and it can damage your esophagus. But so this is part of what causes those chemical changes inside your body with food, and chemically breaks down your food and turns it into energy, glucose that we need, that then gets secreted through the intestines into your bloodstream and powers your cells. And so the only thing or some examples of things, I should say, that are more acidic than the acid in our stomach are battery acid and strong hydrofluoric acid. And so then if we look down at our bases, we've got seawater, which has a pH of 8. Baking soda has a pH of 9. So again, it's 1/100th of pure water. Milk of magnesia, the Great Salt Lake has a pH of 10. Ammonia has a pH of 11. Soapy water has a pH of 12. Bleach's oven cleaner has a pH of 13. Liquid drain cleaner has a pH of 14. Okay? So you can see, right, so there are some things, you know, baking soda, obviously we use for cooking. It's a base. But, you know, ammonia, soapy water, you know, those things we can't eat. So strong bases are just as dangerous to us as strong acids are. And typically we don't typically think of that. So remember to go to Edmodo and to take the video quiz. Thank you.